Welcome. In this explainer, we're going to break down the secret to querying petabytes of data in just seconds. And it all comes down to one absolutely critical design choice in the Vertica analytic database: segmentation.
Okay, so let's just dive right in. How in the world do you tackle a challenge that big? The answer, you might be surprised, isn't just about raw power or throwing more and more hardware at the problem. The real secret is this delicate balancing act. See, on one hand, you've got to spread your data evenly across the whole system so you don't get any bottlenecks. But on the other hand, you need to keep related data physically close together to make your queries just fly. If you get this balance right, you unlock some truly massive performance gains.
Now, to make this concept really clear, we're going to use a simple analogy throughout this guide. Imagine you're moving a giant library. Segmentation is just the master plan for how you load all those books onto your trucks.
So here's our roadmap. We're going to take you all the way from the foundational concepts of distributing data to achieving total mastery of your Vertica design. All right, our journey begins with the most fundamental choice you're going to make for every single table in your database. Do you split the data up, or do you copy it everywhere? You've basically got two primary tools in your toolkit. For your huge tables, you'll want to split them up using what's called a hash function. But for the smaller tables, you're actually going to make full copies on every single machine. I know it sounds a little counterintuitive, but let's see why that is.
Okay, so for your biggest tables, we're talking web logs, financial trades, the really big stuff. The goal is to divide and conquer. Vertica uses a hash function to create a sort of unique digital fingerprint for each row. This makes sure every machine in your cluster gets an equal piece of the pie, which is awesome because it prevents any single node from becoming a performance bottleneck.
But for those smaller, frequently joined dimension tables, redundancy is actually your best friend. By putting a full copy on every node, you completely eliminate the need to shuffle data across the network just to perform a join. And that makes those joins incredibly fast.
So now that we've got the basic options down, let's see how they work together. This next concept, co-location, is literally the single most important principle for getting lightning-fast join performance in Vertica.
Here it is, the crucial point. If you can avoid moving data across the network just to join it, you are going to win the performance game every single time. The whole goal is to make the data you need for a query available right where the computation is happening.
And this is the ultimate prize we're all chasing: a local join. This happens when tables that you join all the time are segmented on the exact same keys. Vertica is smart enough to process that join entirely within each node's local memory. We're talking orders of magnitude faster than shipping data around the cluster. It's a game changer.
And this brings us right back to our library analogy, doesn't it? If you know you're going to need to look up an author's biography when you're looking at their novels, you pack them in the same truck from the very beginning. It's all about intelligent packing to make your research way easier down the line.
But, and this is a big but, to make this all work, you have to choose the right columns to segment on. This is where a concept called cardinality comes in. High cardinality columns are things with lots of unique values, like a transaction ID. Low cardinality columns are things with just a few unique values, like gender. You always want to segment on high cardinality columns to avoid creating these hotspots where one node gets all the work and slows everything down for everybody.
So you've designed for awesome performance, but what about resilience? I mean, what happens when a piece of hardware just fails? Let's take a look at how segmentation plays a crucial role in fault tolerance.
So here's how Vertica builds in that high availability. For every piece of data, what we call a projection, it creates a buddy projection, an exact copy. Then it uses this really clever offset system to make absolutely sure that the primary data and its backup are never, ever stored on the same physical machine. It's just a really elegant solution to a mission-critical problem. And if we go back to our library, this is just like sending a backup truck with an identical set of books, but on a totally different highway. It ensures that even if one highway gets blocked or a truck breaks down, the books can still get to their destination safely. It's all about that built-in redundancy.
Okay, so we've covered the fundamentals of segmentation and fault tolerance. Now let's see how these same principles adapt to the cloud in Vertica's modern cloud-native architecture, which is called Eon mode. In the cloud, the terminology just changes a little bit. Instead of segments, we start talking about shards. But don't let that new word fool you. The core goal of intelligent data distribution remains exactly the same.
Now, just take a look at this slide. It shows the performance impact of getting this right so clearly. On the left, you see a balanced system, right? every node is doing equal work and performance is high. But on the right, you've got an unbalanced ratio, and that creates an instant bottleneck.
So the crucial takeaway here is to just maintain a simple mathematical balance. Your number of shards should always be a multiple or a divisor of your number of nodes. This is what ensures consistent, high performance, and it lets the whole system scale really efficiently.
Okay, so you've designed your whole segmentation strategy. Awesome. But how do you actually know if it's working? Well, let's look at the tools that help you trust but verify.
Your query plans are your source of truth. You are always aiming for that beautiful green checkmark of a local join. If you see words like resegment or broadcast, those are huge red flags telling you that the optimizer is having to move data across the network, which is exactly what we're trying to avoid.
And Vertica gives you a whole toolkit to stay on top of this. I mean, beyond just the explain plans, you can query system tables to check for data skew, and you can even use the Database Designer tool to analyze your workload and recommend the perfect design for you.
So as you go back to your own systems, you've got to ask yourself this question. Are you making the database do unnecessary work, moving data all over the place? Is your warehouse really designed for the fast lane, or is it kind of stuck in traffic? Because mastering this balance of distribution and locality, that is your key to unlocking incredible, game-changing speed.